Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 5, Section 3, Multiplying Rational Numbers. And more specifically, we're going to be talking about multiplying fractions today. Two things we're going to be learning: how you multiply the fractions and why it works. First thing I'm going to teach though is the how. Multiplying fractions is a very simple process. If, for example, I have 3/4 times 1/3, you just simply multiply straight across. So I'm going to do 3 times 1, and I'm going to do 4 times 3. And what you end up with for an answer, the 3 times 1, since you're multiplying your numerators together, okay, you get a new numerator. Since you're multiplying your denominators together, you get a new denominator. So that's really all there is to multiplying fractions. Now, typically though, when you multiply fractions, you need to reduce your answer afterwards. As you can see, I have 3/12, which is a it's not a simplified fraction. It can be reduced further to 1/4 if we reduce both the top and the bottom by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Now when it comes to reducing, I do have a video that explains why that works. That's also part of Chapter 5, Section 3, but that will not be explained in this video. So if you want to know why reducing works, there is a video on that. Just take a look for it in the Chapter 5, Section 3 video section. Now, there are a couple tips and tricks you can use when you're multiplying fractions. And keep in mind, the trick I'm about to show you only works with multiplication. You can only do this when you're multiplying fractions. You cannot do this when you're dividing, adding, or subtracting fractions. This only works, and this is called cross-canceling, or diagonal reducing is another way to think of it. But this only works with multiplying fractions. So what you can do is, normally you can reduce vertically or up and down. Okay, so like if this was 2/4, I could reduce it to 1/2. But when multiplying fractions, I can actually reduce diagonally. This is called cross-canceling. So I have a 3 and a 3, which can be reduced. 3 goes into both 3 and 3, and 3 goes into these numbers one time each. So these 3's can be turned into 1's now. And so now when I multiply, I have 1 times 1, which is 1, and I have 4 times 1, which is 4. And you can see that actually helped me out, because when I got to my answer, I don't have to reduce any longer. My answer is already reduced. Now that doesn't always work out that way. A lot of times when you cross cancel, it actually just makes it so you have to do less reducing when you get to your answer. Because sometimes if you don't cross cancel, you're going to end up with a fraction that's really, really big. You might end up with something like 248 over 372. Which can definitely be reduced, but because it's so big, it may be a little harder to figure out what its simplified form is, because the bigger numbers are, the harder it is to find out if something divides evenly into it. So cross-canceling before you solve the problem can save you a lot of headaches. So now the question is, why does this work? When I am multiplying fractions, such as, let's take 1/2 times 6/8. Okay? Essentially what this is doing, and what happens when you multiply fractions, is this is going to tell you what 1/2 of 6/8 is. Just like when I do something like 6 times 1/2, this is going to tell me what 1/2 of 6 is. When you multiply by a fraction, it tells you what the fractional piece of that number is you're multiplying it by. So what is 1/2 of 6 is essentially what this question is asking. Because if you take a look at it, if I did 6 times 2, I get 12. In other words, I doubled 6. I added 2 6s. If I do 6 times 3, I get 18 because I've added 3 6s. Okay? If I do 6 times 1, I only add 1 6, and so I get 6 for my answer. So it leads us to the conclusion that if we multiply 6 by any number below 1, we should get an answer smaller than 6, because the smaller the number we multiply by, the smaller the answer. And the other thing to keep in mind too is the number I'm multiplying 6 by tells me how many 6s I'm adding, because multiplication is repeated addition. So when I do 6 times 3, it's telling me to add 6 3 times. Repeated addition. When I do 6 times 2, it tells me to add 6 2 times. When I do 6 times 1, it tells me to add 6 1 time. So if I do 6 times 1/2, that's telling me to add 6 half a time. So in other words, what is half of 6? It's 3. So when I'm doing this problem over here, this is actually telling me what half of 6/8 is. That's the ultimate goal of this problem. And because it's multiplication, it can also be reversed. The answer you get will not only tell you what half of 6/8 is, it's also telling you what 6/8 of 1/2 is. But we can talk about that in a different video. Multiplication uses the commutative property, so it doesn't matter which way I flip these numbers or which place these numbers are in, I'll still get the same answer. Just like 6 times 3 also tells me what 3 times 6 is. Okay? That same property is happening here. I can do 1/2 times 6/8 or 6/8 times 1/2. So why does it work? How come I can just go straight across when I multiply? Why does that multiplication work? Well, with the way fractions work, you have to understand the numerator and the denominator. The denominator tells you how many pieces you have. Let me cancel that for a second. The denominator tells me how many pieces equal one whole. So for example, if we're talking about a pizza is sliced into 8 pieces. Now the numerator tells you how many pieces you have. So if I have 6/8, that means it takes 8 pieces to make a whole pizza, and I have 6 slices of those 8. So 2 slices have been eaten. So when you understand that, if I want to find out what 1/2 of 6/8 is, well, like we said, when you multiply by fractions, it typically makes your answer smaller, right? So in this case, I'm trying to find out what half of 6/8 is. So my answer is going to get smaller by 1/2. So in order to find out what half of 6 slices of pizza out of 8 is, I would have to double the bottom, or the total pieces I have, to 16. By doubling the total number of pieces I have, and then keeping the by doubling the total number of pieces that make a whole pizza, and then keeping, we're gonna